Hey mathematicians, it's Justin again. Welcome back. I have been at the Miaville Adventure Park all day, waiting for the opening of their new roller coaster, Fate's Freefall. There's a little more time left before the grand opening, so I've just been hanging out in the arcade. They just added this new game of chance today called Flip of Fate. See, each round consists of 4 coin flips. You have to predict how many times the coin will come up heads and how many times it'll come up tails. If your prediction is right, the figure moves up the mountain, but if you're wrong, the figure moves down the mountain. If you can get the figure to the top of the mountain, you get the grand prize, which is up to over 300 tickets already. Think you can get the prize? What do we know about coin flips? When we flip a coin, there are 2 possible outcomes, heads or tails. What is the probability of landing on heads? Heads is 1 out of 2 outcomes, so the probability is 1/2, or 50%. That means the probability of getting tails is also 1/2, or 50%. Each round of Flip of Fate has 4 coin flips. Out of 4 coin flips, how many heads would you expect? I'd expect heads from half of the 4 flips, so 2 flips should be heads. That also means the other 2 flips should be tails. Flip of Fate? More like predict with probability. Okay, I'm locking in my prediction now. I think I'm gonna get 2 heads and 2 tails. Oh, I got 1 head and 3 tails. That was kind of unexpected. Okay, I'll just play again. Still predicting 2 heads and 2 tails. 4 heads and 0 tails? Oh. Okay, one more time. I'm locking in 2 heads and 2 tails. And it came up 2 heads and 2 tails. Finally. I didn't get the figure to the top of the mountain for the grand prize, but at least I'll get a few tickets for getting my prediction right that time. Based on the probability we calculated, we expected the coin to come up heads half of the time, and tails the other half. But that didn't happen in the game. In the first round of 4 flips, I got 1 heads and 3 tails. In the second round, I got 4 heads and 0 tails. What is going on? Do you think the game is broken since the coin flip results aren't always half heads and half tails? I don't know. When you flip a coin in real life, does it always come up exactly half heads and half tails? I mean, if you flip a coin just once, can it even come up half heads and half tails? No, it has to be either heads or tails. I don't think this means the game is broken, but I'm still not really sure why my results were different than I predicted. Let's take a closer look at the second round where I got 4 heads and 0 tails. We expected to get 2 heads and 2 tails, but we got 4 heads and 0 tails. So 2 of these results were different than what we expected. Is it reasonable for 2 things to happen unexpectedly in the real world? Yeah, absolutely. It's normal for a couple of things to happen unexpectedly and not turn out exactly as predicted. We've been using the word probability to mean a measure of how likely it is for something to happen. But a more accurate term for this is actually theoretical probability. What do you think theoretical means? You might notice the word theory in here. The measure that we get from theoretical probability represents a prediction, or theory, of what we expect to happen. We can calculate theoretical probability just like we have been, without needing to do anything like actually flipping a coin. Doing the action, though, like flipping the coin in this case, is what we call an experiment. Probability experiments are similar to what you may have learned in science class. We start with a hypothesis, which is what we expect to happen based on the theoretical probability. Then we test it to see the actual results. That's the experiment. Let's take another look at flip of fate. We know that when flipping a coin, the theoretical probability of heads is 50%, and the theoretical probability of tails is also 50%. But when I actually played flip of fate, I did not get 50% heads and 50% tails. In the first round, I got 1 heads and 3 tails. Ooh, what part of the time did I get each outcome? I got heads on 1 out of 4 flips, which is 1/4 or 25% of the time, and tails on 3 out of 4 flips, which is 3/4 or 75% of the time. We call these the experimental probability of getting heads and tails, because they summarize the actual results of how often each outcome occurred in the experiment. But I didn't just do this experiment once, I played flip of fate 3 times. The second time, I got 4 heads and 0 tails. And the third time, I got 2 heads and 2 tails. Pause the video here and calculate the experimental probability of getting heads and tails from each of my remaining rounds of flip of fate. In my second round, I got 4 heads out of 4 flips, making the experimental probability 100%. And I got 0 tails out of 4 flips, making the experimental probability 0%. In my third round, I got 2 heads out of 4 flips, making the experimental probability 50%, and 2 tails out of 4 flips, making the experimental probability also 50%. Check this out. Did you notice that the experimental probability was different in each round? It's possible for experimental probability to be the same as the theoretical probability, like the third round. But since experimental probability is based on what actually happens in an experiment, it can and will differ from one experiment to the next, like it did for my first 2 rounds. Let's try one more problem to practice. In the table below, record the theoretical and experimental probabilities of getting each color on the fortune wheel. Oh, hey, I remember this fortune wheel from earlier in the unit. Pause the video here and fill in the top row. What is the theoretical probability of landing on each color? There are 10 total sections on the wheel. 5 are red, so there's a 50% chance of landing on red. 3 sections are blue, so there's a 30% chance of landing on blue. And 2 sections are green for a 20% chance of landing on green. Now for the experimental probability. Let me bring in the bar graph, which shows all of the spins from the last hour. Before we try to calculate the experimental probabilities, how many total spins were there in the last hour? There were 24 red spins, 14 blue spins, and 12 green spins, making 50 total spins. Now that we know how many times the wheel was spun during this experiment, can we determine what the experimental probability was of landing on each color during this hour? Pause the video and calculate it now. All right, let's go over these together. Out of the 50 spins that actually happened during this hour, 24 were red, making an experimental probability of 24 over 50, or 48%. 14 out of the 50 spins were blue, which is 28%. And lastly, 12 out of the 50 spins were green, which is 24%. Notice that none of our experimental probabilities match the theoretical probabilities, but they are pretty close. As we've seen today, theoretical probability, the kind we've been using so far throughout this unit, is helpful for making predictions about what we expect to happen, so we can calculate it before actually doing anything.
If we want an exact measurement of what actually happened, we can run an experiment and calculate the experimental probability based on the outcomes we get. Once you're finished with your guided notes from this video, head over to the online practice to complete levels 1 through 3. Until next time, keep questioning, keep calculating, and remember, theoretical probability is a prediction of what we expect to happen, but what we expect doesn't always happen in the real world. See you next time!